As a review, we're going to begin looking at the idea of the Cartesian coordinate system and also the concept of graphing and calculating the equations for lines. As a reminder, the Cartesian coordinate system is where we have an X and a Y axis where we can plot ordered pairs X and Y. Make sure you know the names of the quadrants, 1, 2, 3, and 4, and that you also know how to plot a point such as 3, 2, you go 3 in the X direction, 2 in the Y direction. Once we are able to plot points, we can then move a step further and plot and graph straight lines. We are going to look at several different forms of straight lines. We are going to look at the slope-intercept form, which is of the form y equals mx plus b, where m is the slope and b is the y-intercept. Remember, by definition, a y-intercept is where x equals 0. Secondly, we're going to look at the standard form of the equation. In the standard form of the equation, it's of the form ax plus by equals c. And here, to find the slope, we would use the formula negative a over b to find the slope. And to find the y-intercept, we would plug in 0 for x and then solve for y. And finally, point slope form is the third form that you will need to know. It is of the form y equals y1, y minus y1 equals m times x minus x1. Again, the slope is right here. And to find the y-intercept, you would plug in 0 for x and solve for y. Note all of these equations are what we consider first degree because the exponent of x is simply 1. There are types of slope that you need to know, and you need to be able to identify those. For example, a line can have positive slope, where it's going up from left to right. A line can have negative slope, and a line can also have 0 slope, which is a horizontal line, or it can have undefined slope, where it is a vertical line. You need to be able to calculate slope or the measure of steepness of a graph. You can calculate the slope by taking the 2 points and doing y2 minus y1 over x2 minus x1. Or if you have a graph, you can find the slope by counting the rise over the run from one point to the next. Let's consider an example here shortly where we're going to take that idea and we're going to use it to find the equation of a line. One of the big concepts we'll be working on this class is finding the equation of a tangent line. And so in order to do that, we have to be able to find the equation of a line. There are 4 steps listed here for finding the equation of a line. You must find the slope, you must plug in the slope, plug in a known point, and finally put it in proper form. So let's consider the example where we want to find the equation of a line that passes through the point -2, 3. So to give us an idea here, and 5, -1. So notice our line is going to have negative slope. So that's one way we can check it first of all. But following those 4 steps for finding the equation of a line, we need to find the slope. We can do that by counting rise over run, which works well when they're whole numbers. But if they're not whole numbers, then we need to be able to deal with fractions. So let's practice that concept. To do y2 minus y1, we're going to do -1 minus 3. So we have x, y, and over 5 minus a -2. Remember, minus a negative becomes plus a positive. Up top, we end up with -4 over 7, which is a negative slope. Our second step then is to plug in that slope. I like to use slope-intercept form. And the only part we know at this point is the slope. And now I can plug in a known point. I can use either one of these points that I've been given. I am going to use the point 5, -1. -1 goes in for y, -4/7 times 5 plus b. And when I calculate, I get -20/7 plus b, adding 20/7 to both sides. Here, -1, I can list as -7/7 plus 20/7. These cancel, is going to give me a b value of 13/7. So my equation of my line is y equals -4/7 x plus 13/7. Note the y-intercept right here, 13/7, seems reasonable as it is less than 2. Please do note equations for special lines. Horizontal lines are always of the form y equals. So for example, this line would be perhaps y equals 3. Vertical lines are always of the form x equals. So this line might perhaps be x equals -2. The x value is always the same no matter what. And finally, please do remember that for parallel lines, the slopes are going to be equivalent. For perpendicular lines, the slope will be the negative reciprocal. This is for parallel, and this is for perpendicular.